everyone, this is Ritik Auri from Management Plus. In this video, we will discuss Pandas Library in Python. We will base our discussion on straightforward examples throughout this video for better understanding. So let's get started with our very first topic, which is what is Pandas? So what is Pandas? Pandas is a Python package for high-performance data analysis. It provides fast, powerful and very flexible data structures for data analysis and data manipulation. Okay, now why Pandas? Well, data science and machine learning depend on the data. Raw data cannot be used for analysis and creating machine models. We need to collect data from multiple channels, process it and prepare it for analysis. Only then we can build machine learning models on top of that data. Here Pandas module comes in picture. Pandas module eases various operations for us, like importing of data from multiple sources. For example, CSV files, Excel files, different databases, big data. Loading data into heterogeneous tabular format data structure, that is data frame. A data frame stores the data in rows and columns. Also, in a single row or column, data can be of different types. Manipulation of data, that is routines for handling missing data, dataset merging, reshaping of datasets, time series based analysis, group by, breakup of data, that is split apply combine operations. Integration with other visualization libraries like Matplotlib and Plotly. While Pandas module provides several data structures for data manipulation and analysis, the two most common data structures used are series and DataFrame. Let's talk about series first. What is series? Series is a heterogeneous one-dimensional labeled array. It contains sequence of values for any data type. It is mainly used with data frames. These are row index labels, which can be numbers or some other strings, and these are values. We will see how series is used with data frames in the upcoming examples. But before that, let's discuss what is data frame. So, what is a data frame? Data frame is a heterogeneous n-dimensional labeled data structure. But in most cases, it is used as a two-dimensional tabular format. In two-dimensional format, it stores data in rows and columns like this. All the rows and columns in data frame are labeled. These are column names and these are row index labels. A data frame is similar to an Excel worksheet, and like in Excel, we can perform data analysis on data frames using different APIs. Now let's move ahead and look at some of the basic and wonderful operations that we can perform on a data frame using different examples. Pandas provides us APIs to import data from CSV files to data frame. Suppose we have a CSV file, we can import this CSV file to a data frame like this. The first row here becomes the column headers in the data frame. We can also provide custom row labels while importing the data. Importing of data is not limited to CSV files. We can also import from Excel sheets, databases, big data, etc. Next is selecting rows, columns of a data frame. Assuming that we have a data frame something like this, we can select rows or columns from this data frame. For example, we fetched the column age of data frame as a series object. Each value in this fetched column has a row index label associated with it. Similarly, we can fetch row 2 of data frame as a series object. Each value in this fetched row has a column name associated with it. When we select a single row or column from the data frame, then the data is returned as a series object. At this point of time, let me reiterate that a series is one-dimensional labeled array and it provides several methods for data manipulation and data analysis. Using these APIs, we can perform various operations like finding the average of values in a selected row or column, or finding minimum or maximum value from the selected row or column. There are many more operations which you can perform using Series API. Next is replacing Nan values in data frame. Assuming that we have a data frame something like this, which lost some data while importing raw data. In Pandas, the missing values are denoted by Nan. So, based on your requirement, you can replace these values with any appropriate data. For example, a sample Pandas API replaced the missing values with the mean of all the values of the column. Other useful operation is sorting data frame. Let's say we want to sort this data frame based on age column values. We can do the same using Pandas Library. Pandas libraries also provide support for filtering data from a data frame. Assuming from this data frame, we can select only those values where the age of employees is greater than 48. Another very elementary but advantageous operation is group by in data frame. Group by mechanism in Pandas provides a way to break the data frame into multiple groups or chunks. These splits can be based on the values of single or multiple columns. Let's take an example. Assuming that we have a data frame, something like this. This data frame has column city, which has 3 unique values: Delhi, Mumbai and Sydney. Now we want to create different groups from this data frame based on city column. As this column has only 3 unique values, the Pandas library will form 3 groups. Group 1 will have all the rows for which column city has value Delhi. Group 2 will include all the rows for which column city has value Mumbai. Group 3 will include all the rows which column city has the value Sydney. Although Pandas library is used quite a lot for data manipulation and data analysis, and we discussed many data manipulation and data analysis examples. Let's also see an example for data visualization, as Pandas library is well integrated with different visualization modules in Python like matplotlib. We can easily convert Pandas data frame to different types of graphs. Assuming that we have a data frame something like this. This data frame contains random numbers in each column named x1, x2, x3 and x4. We can convert this data frame to line plot graphs. This is a line chart made with a single function call. Each column of the data frame is represented by a line differentiated by colors. For example, x1 is represented by blue, x2 is represented by orange, x3 is represented by green, and x4 is represented by red. With a few tweaks in function parameters, you can also generate subplots instead of one big chart. Like here, we converted each column of the data frame into separate line chart, and it again requires just a single line of code. x1 is represented by a separate line chart, similarly x2, x3, x4. In addition to line charts, we can also convert a data frame to bar chart, and that too with a single line of code. Let's take the same data frame and let's convert it into a bar chart. This is a vertical bar chart. Here we plotted each column as a separate color bar in the chart. Again, with small tweaks in the parameters, we can convert the data frame into a horizontal bar chart as well. Something like this. Well, if all this can be done with a single line of code, I would say that Pandas is amazing. Okay, we saw creating lines and bar charts, but we can create several other types of charts from Pandas data frame, like a histogram, box plots, area plots. There are many more different kinds of visualizations that we can generate using Pandas by integrating Pandas with other visualization libraries like Plotly. You can create interactive dashboards as well in Python. Before closing, I would say that Pandas provides you with the APIs for data loading, manipulation, analysis, and visualization. Well, that was all I wanted to discuss in this video. We touched upon what is Pandas, why we need Pandas. We also walked through Series and DataFrame with easy and straightforward examples. I hope you liked the video. Please communicate your views with me in the comment section. Do share this video more and more. Subscribe the channel. Bye for now and thank you for watching.